गुड मॉर्निंग बच्चों। आज हम सिग्निफिकेंट फिगर्स के बारे में डिस्कस करेंगे। सिग्निफिकेंट फिगर्स की ज़रूरत क्यों आई? जैसे हमारा कोई मेजरमेंट अगर हम करते हैं, मान लीजिए मेजरिंग स्केल से करते हैं, तो हमने किया 4.2 सेंटीमीटर से, बिकॉज द मेजरिंग स्केल का जो लीस्ट काउंट है दैट इज 0.1 सेंटीमीटर और 1 मिलीमीटर। दिस इज द लीस्ट काउंट, यानी इससे कम वैल्यू हम उसकी मेजर नहीं कर सकते हैं। वी कैन मेजर अप टू 1 mm, नॉट बिलो दैट। सो दिस इज कॉल्ड द लीस्ट काउंट ऑफ मेजरिंग स्केल। तो हर एक इंस्ट्रूमेंट का अलग अलग लीस्ट काउंट होता है। मान लीजिए आपके पास स्क्रू गेज है, स्क्रू गेज का जो लीस्ट काउंट है दैट इज 0.01 mm और वी कैन से 0.001 सेंटीमीटर। तो हम मेजरमेंट जो करेंगे लेंथ का, मान लो किसी रोड का मेजर करना है तो वी कैन मेजर अप टू से 4.215। ओके, सो वी कैन मेजर अप टू मोर एक्यूरेसी दिस मच सेंटीमीटर। अभी ये हो गया हमारा लीस्ट काउंट के बेस पे। अब भाई व्हाट इज द डिफरेंस बिटवीन प्रेसिजन एंड एक्यूरेसी? समटाइम्स हम बोलते हैं कि द मेजरमेंट इज वेरी प्रिसाइज एंड समटाइम्स वी से इज वेरी एक्यूरेट। मान लीजिए कोई वैल्यू है लेंथ की, एक्चुअल वैल्यू जो है उसकी लेंथ की, सपोज दिस इज से 4.5 सेंटीमीटर। ओके, अगर हमने 3 डिफरेंट मेजरमेंट्स किए और 3 डिफरेंट मेजरमेंट्स में से एक आया 3.96, एक आया 3.98 और दूसरा आया मेरा 4.00। ओके, सो दे आर वेरी प्रिसाइज बट दे आर नॉट एक्यूरेट बिकॉज दे आर नॉट नियर टू 4.5। और दूसरे जो मेजरमेंट किया हमने, एक रीडिंग आई 4.0 सेंटीमीटर, एक आई 4.5 और एक आई 5.0। सो दीज आर एक्यूरेट but they are not precise because one value is 4.5 which is matching with the actual value. So they are accurate but not precise. They are precise but not accurate. अभी सिग्निफिकेंट फिगर की कंसेप्ट कहाँ से आई? मान लीजिए आपको मैंने बोला what is the value of 1.50 into 2. Okay, so you can say that the value of this is nothing but 3. Then the answer will be wrong because the significant figures here are 3. So you have to write the answer in 3 significant figures. So the real answer will be 3.00. Now we will go in detail how these significant figures are arrived. For say I tell you subtract 1.5 from say 3.15. Okay, then what you can write? 3.15 subtract 1.5. So it will be 5, 11 minus 5, 6. So it should be 1.65. Okay, but the answer will be wrong. You have to write the answer in up to 2 decimals. That is the least decimal place. So up to 1 decimal only we have to write the answer. So answer should be 1.6 after rounding up. Okay, so this we will study how to round up the figure, everything. So this is the concept of significant figures. Now we will go in detail how to arrive at the number of significant figures in a given number. So there are 3 rules. Number 1 rule is all non-zero numbers are significant. We will take examples of each rule. All non-zero numbers are significant. Say I write 1, 1, 2, 8, 6. So how many significant figures are there? 5 significant figures are there. Or I say write 1.256. So again there are 4 significant figures. The number 2 rule is if there are zeros, then zeros between 2 significant figures, all zeros between 2 significant figures will be significant. They will be significant. What is the meaning? Suppose I give the number 1008. So how many significant figures are there? 4. Why? Because these 2 zeros, they lie between the 2 non-zero numbers which are significant. So it has 4 numbers of significant figures. Suppose I write 1080. How many significant figures? Only 3. Because this 0 is not significant as it does not lie between the 2 significant figures or between the 2 non-zero numbers. Okay, so these are the 2 rules. Then third rule is when the zeros will be significant, zeros, if it is a decimal number, then zeros are significant when after the decimal, and at the end. So these two criteria they have to satisfy. The zero should be after the decimal and at the end. Let us take one example. Suppose I write 1.080. Okay. So how many significant figures are there? 4. Because this 0 is significant because it is after the decimal and at the end. And why this 0 is significant? Because all zeros between two significant figures will be significant. Now this 0 is significant, so this 1 is significant. So all zeros lying between two significant figures will be significant. So there will be 4 significant figures. We will take few more examples to understand the rules. Suppose I give you the number 0.0080. So how many significant figures are there? This 0 is significant because it is after the decimal and at the end. 8 is significant because this is non-zero number. So only 2 numbers are significant. These zeros will not be significant because they are not at the end. Okay, though they are after the decimal but not at the end, and they are not between two significant figures. Suppose I write 1.0080. Then how many significant figures? There will be 1, 2, 3, 4, 5. So 5 significant figures. Now these two zeros are also significant because they lie between two significant figures. This 0 is significant because it is after the decimal and at the end. This 1 is significant because it is non-zero number. So these two zeros which lie between two significant figures will also be significant, and we have 5 significant figures in this case. Suppose I write 10800. So how many significant figures are there? Only these 3. Because these two zeros are not after the decimal and at the end, so they are not significant. So that is how you can write. Then one more rule is 10 to the power anything, say 10 to the power 5 or 10 to the power 6, they will be non-significant. They are not significant. So suppose I give you the number, let us consider a number 1.050. Okay, how many significant figures are there? 1, 2, 3, 4. So even if I write 10 to the power 4, it will have 4 significant figures. These 4 only. Okay. Suppose I give you 500.00. Write it in the scientific notation. So we know there are how many significant figures? 1, 2, 3, 4, 5. So it has 5 significant figures. This 0 is significant because it is after the decimal and at the end. And these zeros are significant because they are between the two significant figures, between this significant figure and this. So it has total how many significant figures? 5. I write in the scientific notation, I will write as 5.0000 into 10 to the power 2. Okay. Because we have to see that it should contain 5 significant figures. 10 to the power 2 is not significant figure. So how many? 1, 2, 3, 4, 5. So total 5 significant figures has to be there. So that is how we can know the number of significant figures. Now suppose I want to multiply. Okay, say 1.3 into 2.886 divided by say 1.025. Okay, so the answer should have how many significant figures? The least one, that is 2 significant figures. So I will calculate this out, then whatever the number comes, I will round up that number up to 1 decimal, so that this should have only 2 significant figures. In the answer should have only 2 significant figures because that is the least. Though this has 4 significant figures, this has 4, but the answer should have only 2 significant figures. This is in case of multiplication or division. Suppose I want to addition. For addition and subtraction, this rule is the result or the answer should be up to the least number of decimal places. Means suppose I give you that add 1.2 plus 1.308. Okay, so the answer should have only up to 1 decimal. So first I will add this, so 1.308, I will simply add 1.2, the answer will be 80325 and 2. So answer is 2.508. But this answer I have to write up to only 1 decimal place. So the actual answer will not be this, the answer will be 2.5. I will round up this answer up to 1 decimal place. So 2.5. So that is the rule for addition and subtraction. And this is the rule for multiplication and division. So for multiplication and division, the answer should be in the least number of significant figures of the given numbers, and for addition and subtraction, it should be up to the least number of decimal places in the given numbers. So that is the rules for significant numbers. Now, if I give you some examples of rounding up, suppose I want to round up some numbers. Okay, so let us see. How to round up. Suppose it is given that round up 74.3867. Okay, this number is to be rounded up. How many significant figures are there? 1, 2, 3, 4, 5, 6. Suppose I tell you, you round up to 5 significant figures. So its answer will be 74.35 we have to take. So 3, 8, this will round up to 7. Because 7 is more than 5, so it will be 3.74.387. Suppose I want to round up to 4 significant figures. Then answer will be 74.39. Because this 7 is more than 5, so round up is 74.39. This is 4. Now I round up to say 3 significant figures. Then the answer will be 74.4. Because 9 is greater than 5, so it will be 74.4. Okay, so that is how we can round up. Suppose for 2 significant figures, the answer will be 74. Okay, because this 4 is less than 5, so it will be 74. If I round up to say 1 significant figure, okay, then answer will be 70. Okay, why 70 has 1 significant figure? Because this 0 is not significant. It is not after the decimal or not at the end of decimal. So this 0 is not significant. So it is up to 1 decimal place. Okay, if it had been 76, then this round up would be 80. Okay, because if it is more than 5, it will be 80. So that is how we can round up the various numbers. The question arises when this 1.226, suppose this I want to round up to 3 significant figures, then it will be 1.23. And suppose I give you 1.225, then how to round up? So there is a convention that whenever this 5 is before the 5 there is a even digit, then the round up will be 1.22 as it is. And suppose if it is say 1.235, then the round up will be increased by 1, so 1.24. Okay, so this is how, because this 3 is odd, so this round up will increase by 1 and it is 5 after the 3. So that is how we can round up the various figures. With this, we have almost completed our discussion on significant figures and how to round up the various given numbers. With this, we conclude. Okay, we will meet in the next session. Thank you. Wishing all the best.